Hello, today I will be presenting Curving the Line, Circularity in the Data Center Industry. My name is Beth Whitehead and I am an Associate Sustainability Engineer at Operational Intelligence. We are engineers that use collaborative working with a blend of consultancy and training to reduce data center risk, energy, cost, and environmental impact. And my particular area of expertise is in data center lifecycle assessment. Deborah Andrews, who is doing the Q&A session, is an Associate Professor of Design in the School of Engineering at LSBU, with 20 plus years of experience in sustainable design and manufacture and the circular economy. So, first a little bit of background. Since the inception of the Internet in the 1980s, the number of users has grown to over 4.5 billion people, and 59% of the global population are now connected. While devices such as desktop and laptop computers and mobile phones serve as human digital data interfaces, the hidden but critical enablers of connectivity are data centers. These facilities can be as simple as a single rack in a server closet or as complex as a large warehouse, but all house digital data processing, networking, and storage equipment. Such is the popularity of the Internet that in 2015, the number of data centers around the world peaked at 8.6 million. And although their numbers are showing a downward trend, our reliance on them continues to grow. Access to cheaper mobile technology, the increasing digitalization of our world, and more of the global population connecting and on more devices is one part of this growing reliance. The fourth industrial revolution, in which we embed technologies and infrastructures of the third industrial revolution in new ways within society to create cyber-physical systems, is driving this increasing connectivity. As the fourth industrial revolution progresses, the volume of data generated by an expansion of services powered by the Internet of Things in creating smart cities alongside other data-intensive technologies like AI, blockchain, and robotics, means our demand on data centers is ever increasing. Indeed, the World Economic Forum predicted that by this year, more than 50 billion things, ranging from cranes to coffee machines, would be connected to the Internet. Although recent estimates by IDC suggest this to be lower at 41.6 billion connected things, generating 79.4 zettabytes of data by 2025, it's clear that our reliance is in a period of explosion. As our connectivity increases, data center numbers are showing a downward trend and a slowing in the increase of energy consumption due to efficiency measures. For example, virtualization has led to diminishing growth rates in shipped server numbers. The movement of services to co-location and the cloud allows for maximum productivity and better utilization rates, and power demand per server has plateaued, all of which have led to improved energy efficiency. However, our reliance on them continues to grow, and with concerns starting in a period of low renewables content in the grid, the industry has historically focused heavily on energy consumption, meaning our approach to materials use has been sidelined. Although ICT has become more energy efficient, rebound effects have led to a higher demand and more devices, cancelling out any potential to save overall impact. The fourth industrial revolution sees us manufacturing more components to support and enable the Internet of Things and smart cities. Although digitalization and the Internet of Things are theoretically enablers for a decrease in resource demand, enabling multiple users of single smart devices, software-induced obsolescence means in practice the opposite is happening. As grids become more renewables-based, we need to expand the boundaries under consideration beyond just energy and to consider more holistically the way in which we use resources. Let's have a look at problems associated with a linear model of consumption for servers. In a linear model, we take resources from the ground, make them into servers, use them, and then dispose of them. First, we take raw materials. These are finite. We don't have an endless supply and are often stockpiled. They will run out, and the ICT industry is not the only industry using them. In addition, many of these raw materials are considered critical. Critical raw materials are politically volatile, with most supplies imported from outside the European Union and are of high economic value and result in low security in the supply chain. They are essential to the data center industry, and disruption in their supply would negatively affect the digital economy. Critical raw materials are mainly found in batteries, drives like hard disk drives and solid state drives, PCBs, and connectors. The most abundant critical raw materials found in servers are neodymium in HDD magnets, cobalt in batteries, and silicon metal in the integrated circuits and PCBs. Then we make a product. Here we need to find new ways to reduce our reliance on critical raw materials and overall material consumption. For example, shared fans per group of servers rather than fans per server can reduce material consumption. In addition, OEMs often manufacture servers which reach an end of life through software-induced obsolescence rather than a functional or material end of life. And a lack of standardization in design and gratuitous differentiation between different generations of servers means reuse and refurbishment is often difficult. The industry needs improved policy and guidelines to prevent these barriers to life extension of products. During the use phase, product lifetimes are often short and trust in data sanitization low, meaning many items are crushed before the end of their usable lifetimes. Fear of data loss also leads to stockpiling of unused equipment, meaning materials are unused but not unreleased from previous products. Also, over-provisioning and redundant servers left plugged in sees servers online but doing little or no useful work. Misconception of secondary goods as inferior and warranty-free means secondary and tertiary markets are yet to be fully realised to their full potential and has led to procurement barriers to their use. Finally, we reach disposal. E-waste is growing. Global IT waste is set to exceed 120 million tonnes by 2050. In the 4 years between 2019 and 2023, almost 46 million servers will be decommissioned. In addition, recycling rates globally are low. In the EU, just 35% is officially reported as properly collected and recycled. However, the global average is much lower at 20%. Much of the remaining 80% goes to landfill. This means we are burying large quantities of valuable materials. For servers that are recycled, critical raw materials have very low and negligible reclamation rates. Often materials are hard to recover as they are mixed within products, such as antimony, used as a flame retardant in PCB plastics. We also don't have the infrastructure for dealing with this waste. The reprocessing methods used are underdeveloped, and the process of recovering materials and metals is expensive. Consequently, there is a real and urgent need to address this now. We can't continue as we are. The Lean ICT report showed that our current global digital consumption is resulting in unsustainable levels of energy and materials use, and the fourth industrial revolution simply won't be possible under our current linear model of consumption. We need to curve the line and close the materials loop now, adopting a circular economy in which we use a life cycle perspective, considering material and energy use, economic and social impact at all phases of the life cycle, eliminating burden shift, and work collaboratively in a multi-stakeholder environment to find solutions. With a closed loop, we can maximise the inherent value of materials within products, ensuring secondary and tertiary lifetimes of products, and creating secure supply chains. In adopting regenerative circular models of business, we need to take less raw materials, improve design to reduce material consumption, investigate material swaps, and end gratuitous differentiation between generations of models, and to ensure ease of reuse and refurbishment. Stop the stockpiling of products and materials with high material value. use open-sourced hardware and software, making sustainable ICT available to all, and to end planned obsolescence. We need to enter into a period of digital sobriety where we move to leaner ICT, where we use the least powerful equipment possible with the longest lifetimes and put a limit on unnecessary energy-intensive uses. Reframe end of life as end of use and waste as a valuable secondary resource. Lengthen lifetimes through reuse and refurbishment, and build the infrastructure to improve material recovery outcomes at the end of use. For digitalisation to deliver environmental sustainability, we need to decouple environmental impact from economic growth to ensure the economy can recover post-pandemic. In the period from 1995 to 2017, although the EU and US saw a slight decrease in carbon emissions and energy consumption, alongside continued growth in ICT and GDP, in China and India, energy consumption and emissions increased significantly, alongside much greater economic growth. Post-COVID-19, the industry should seek to rebuild the economy through circular business models to ensure we alleviate pressure on raw materials, energy and end-of-life infrastructure, and to ensure economic growth and a reduction in unemployment rates. So, now to introduce SEDASI. SEDASI, a circular economy for the data center industry, aims to enable trans-sectoral and transnational learning and develop circular economy solutions for the data center industry in Northwest Europe. It is an EU-funded Interreg project with an initial focus on critical raw materials in servers. The project will build a circular economy for the data center industry. To increase dematerialization through improved eco-design guidelines for circular economy, extend product life through equipment reuse and refurbishment, increase reclamation and reuse of critical raw materials in the sector, reduce the use of virgin materials, waste and environmental impact arising from the growth in redundant equipment, develop a secure and economically viable critical raw material supply chain for the sector, increase collection, processing and recycling in the EU and adherence to EU regulations, provide an approach that can be applied to all equipment within the facility, create jobs in Northwest Europe, decrease illegal export of sectoral limit stockpiling of resources overseas, and ensure the control of Northwest Europe data center industry materials supply chain and manufacture. And here is our vision for the project. SEDASI is an interdisciplinary multi-output initiative that uses whole life cycle thinking and brings together a network of stakeholders from all subsectors of the data center industry to share knowledge and collaborate to develop a sectoral circular economy. It will reduce waste and prevent supply chain problems to secure uninterrupted data center operation and service in the future. The project has 4 project partner countries, the UK, France, the Netherlands and Germany, with a lead partner in each country and additional sub and associated partners. The lead partners are LSBU in the UK, WeLoop in France, Green IT Amsterdam in the Netherlands, and the Wuppertal Institute for Climate, Environment and Energy in Germany. For the industry to grow and adapt, it's important not to exist in silos. There must be opportunity for knowledge transfer to ensure methodologies are created collaboratively through an understanding of the whole problem and not focused on small parts. This approach helps individuals to gain ownership of problems and breaks down contractual boundaries over which knowledge wouldn't normally flow. Each member of the project team therefore brings expertise from different areas. This knowledge base is increased by working groups in each country which support and guide the research process through working group meetings and national and international co-creation workshops. These include people with knowledge of the full life cycle, including those involved in the supply chain, design, manufacturing, R&D, procurement, use, transportation, data sanitization, reuse and refurbishment, recycling, and policy and communication, and are all members of the wider SUDASI network. The multidisciplinary transnational knowledge-sharing SUDASI network brings together stakeholders from all life cycle stages and subsectors, directly and indirectly associated with the data center industry. The aim of the network is to maximize transfer of expertise between stakeholders and the project, demonstrate the feasibility and benefits of circular economy practice, and boost sectoral uptake. Members can share ideas within a multi-professional network and inform the research process, access innovative insights towards circular solutions through example case studies, test, develop and use circular business models and CDCC, the Circular Data Center Compass, which is a virtual decision-making tool, and enlarge their national and European business network and identify business opportunities. And anyone with knowledge or interest in the topic can join. Working alongside our working group members, 3 integrated pilots covering 3 life cycle stages, design and manufacture, life extension and end of life, will allow for the following outputs: eco-design and design for circular economy guidelines to accelerate manufacture of circular economy fit products, life cycle assessment methods and a database of components and materials, CDCC, the virtual decision-making tool with a multi-step approach to optimize circular economy business models, and improved refurbishment, recycling and reclamation strategies for WEEE and critical raw materials. These outputs will feed into bespoke one-to-one technical assistance, including CDCC training sessions for 50 SMEs, advice and guidelines for policy influencers and makers, eco-design guidelines for circular economy, a physical and virtual demonstrator that explains the CE context, processes and benefits, and development of a circular economy for the data center industry. A long-term strategy with 10-year maintenance plan will ensure the project impact and long-term legacy. Originally named as the decision-making tool, CDCC, or the Circular Data Center Compass, is currently being designed and developed by the SUDASI team to guide and support the data center industry in implementing circular solutions in their day-to-day activities. The potential key features of the tool are assessed through 3 perspectives: design, remanufacturing and recycling in the UK, and through 2 groups of experts in the Netherlands looking at design and supply and refurbishment and recycling. That draws my presentation to an end. Thank you for listening. Deborah will now happily answer any questions you might have, and if you have any further queries, please feel free to reach out through our contact details below.